So let me introduce you another method of solving the differential equation of order 1 with exact equation. So for our second method or alternative solution, we have the general equation or formula. So the summation of the integral of direct integration plus the integral of non-direct integration equals to the integral of 0. So di equals to direct integration, or we have px dx, qx dx, hy dy, and py dy. For the NDI or non-direct integration, we have the f xy dy and q xy dx. So we have two steps to solve the equation. First, arrange the equation into general equation, taking all direct integrable in m and n, choosing direct non-integrable in m and n. Then second, integrate di and ndi. Integrate ndi partially with respect to the particular variable, taking one as constant. So for our example, solve the quantity of x plus y dx plus x minus y dy equals to 0. So our formula, we have the summation of the integral of di plus the integral of ndi equals to the integral of 0. So first, distribute dx and dy and expand. Then we have x dx plus y dx plus x dy minus y dy equals to 0. So for our direct integrand, we have x dx and negative y dy. Then for our ndi, we have y dx and x dy. Then next, choose y dx in our ndi. Then use the formula. We have now the summation of the integral of di plus the integral of ndi equals to the integral of 0. Or we have the integral of x dx. So we have the integral of x dx minus the integral of y dy plus the integral of y dx equals to 0. Or we have x squared over 2 minus y squared over 2 plus xy equals to c. Or for example, we choose x dy instead of y dx. Still, if we integrate x dy, we still have xy plus c. The same answer as if we integrate y dx. Since if we integrate x dy, holding x constant, so we have the integral of y, dy, which is equal to y. Here, if we integrate y dx, then y is constant. Integral of dx is x, so we still have xy. So simplifying the equation, we have x squared minus y squared plus 2xy equals to 2c and equal to c. Then we have x squared plus 2xy minus y squared equals to c. Then another example, solve the equation of the quantity of 6x plus y squared dx plus y times the quantity of 2x minus 3y dy equals to 0. Then again, from our formula, summation of the integral of di plus the integral of ndi equals to the integral of 0. Then next, distribute dx and dy. So we have now 6x dx plus y squared dx plus 2xy dy minus 3y squared dy equals to 0. Then for our di, we have 6x dx, then negative 3y squared dy. For our ndi, we have y squared dx, then 2xy dy. The next, so we choose y squared dx as our ndi. Then using the formula of the summation of integral of di plus integral of ndi equals to the integral of 0. So we have the integral of 6x dx minus the integral of 3y squared dy plus the integral of y squared dx equals to the integral of 0. We have 3x squared minus y cubed plus xy squared equals to 0. Or we have 3x squared plus xy squared minus y cubed equals to c. So for example, you want to choose 2xy dy. Then if we integrate to xy dy holding 2x as constant, then still we have 2x times y squared over 2 or xy squared plus c.